Okay, so in this one, I'm doing an example of the rational roots theorem. So this is coming from your book, example number 30. So in 25 through 32, it says find all the real solutions of the equation. And for number 30, this is what I have. So just to go over what the rational roots theorem is. So rational roots theorem. What this says, it gives you a list of possible solutions to your polynomial equation. And so it's stated like this: P over Q is a possible solution to your equation. Well, P are the factors of the coefficient. So in this case, it'd be 72 divided by Q, which is the factors of the leading coefficient. In this case, it would be 1. So 72 I get from here. So the numerator are the leading coefficients of, the factors of the coefficient, and 1 is the leading coefficient. Okay, so I'm going to list all the factors that I know of these of these numbers. So, and I'm going to consider the positive and negative. So I know positive and negative 1 are factors of 72. Okay, that also means plus or minus 72 is a factor. So I'm going to go through these. I'm using a calculator to help me find these, by the way. So I'll do 72 divided by 2, and it is indeed divisible by 2. So I know that plus or minus 2 is a factor of 72, and plus or minus 36 is a factor. Because 72 divided by 2 is 36. I'll do 72 divided by 3, so it's divisible, so plus or minus 3, plus or minus 24. 72 divided by 4, and I get plus or minus 18, plus or minus 4, and it would have to go with 18. So 72 isn't divisible by 5, but 72 should be divisible by 6, and it is. So plus or minus 6, and plus or minus 12. I believe 72 is divisible by 8, it is. So plus or minus 8, and plus or minus 9. Okay, so I've completed this list of all the factors of 72. Okay, now all of these are factors of 72, and we divide it by possible factors of 1, which are just positive and negative 1. So here's the concept behind the rational roots theorem, is that 1 over 1, which is 1, is a possible root of this polynomial. Negative 1 over positive 1, so negative 1 is also 1. 2 over 1 and 2 over negative 1. So on and so forth. So there's a lot of possibilities here, and I don't expect you guys to go through and test them. Now, what the book would like you to have you do is to go and test them using synthetic division. So I could take a value from my list of possibilities. So I could say 3. And I could take 3 and I can use synthetic division, what we learned last unit, and I could divide, and if I get a remainder of 0, that means it's a solution. Now, I don't expect you guys to go through and do that for every single possible one, especially when we have a list this huge. So, rather, what we could do is graph this polynomial in Desmos, and pretty much just give us a quicker route. So for 30, we said the equation is x cubed minus 16x squared plus 55x plus 72. So where it crosses the x-axis, these are the points I'm most interested in. So negative 1, 8, and 9. So you could see here that negative 1, 8, and 9 are on our possible solutions. Okay, so that will tell us how we can give us a quicker route, because I don't want you guys to be testing all day, and that would honestly take way too long. So in any case, let's just use synthetic division for these ones. So we said -1, 8, and 9 are our solutions. So let's just make sure that those are right using synthetic division. So I have 1, -16, 55, 72. Okay. Drop the 1. 1 times -1 is -1. That gives me -17. -17 times -1 is +17. 55 plus 17 is 72. 72 times -1 is -72. And when I add those together, I get 0. And so this right here, x squared minus 17x plus 72, is equal to, and this is our remainder. Okay. Now what this has helped me do, it helped me to reduce my polynomial. Now this means that x plus 1 is a factor. X plus 1 is a factor. Now we could use this to help me factor the rest of this, but here's the thing, we already know what the remaining two factors are going to be, 8 and 9, so this should factor into x minus 8 and x minus 9. So if we do the math here, -8 and -9 multiplied together gives me +72, but added together gives me -17. So pretty much what we've done here is just confirmed that these roots are indeed the roots that we needed. So we know that x is equal to -1, 8, and 9. Okay, so we use the rational roots theorem to help us come up with a list of possibilities. We graphed the polynomial to help us confirm which of the possibilities are indeed our roots, and we just double checked by making sure that it factored correctly. Okay, let's do another one. This one I'll pull as number 34 from the book. It says find all the real zeros of the function. So examples 33 through 38, these are what examples you'll look for. So 33 through 38 to find all the real zeros of the function. So 34, g of x is equal to x cubed minus 28x minus 48. Okay, now I'm not sure if anyone's noticed a pattern here, but the degree of a polynomial is very telling of how many solutions we're going to have. So 3, this one had 3 and we had 3 solutions. So this one had 5. We came up with 3, but also remember that we had a duplicate of this one 3 times. So 1, 2, 3, 4, and 5. Up here we had 1, 2, and 3, and the degree was 3. We're going to talk a little bit about this more next time, but just note that the degree tells us how many solutions we're going to have. So let's see. So find all the real zeros of the function. Now that's the key though. It says real zeros. We might not be able to, not all our zeros are going to be real. But in any case, so let's use the rational roots theorem here, because I don't believe I could factor this right now as it is. So let's use the rational roots theorem to help us find a list of possibilities that we could use and then graph. Okay, so we could take factors of, let's say, 48. So the rational roots theorem says factors of 48 over factors of 1. So factors of 48 would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus, I don't think 48 is divisible, oh, it is divisible by 6, so plus or minus 6, and then 8, let's see, 48 divided by 4, so plus or minus 12, 16, 24, and 48. I guess I didn't really need these commas here, but so those are all the factors of that, and then divided by all the factors of 1. So that'd be 1 and -1. So here are a list of possibilities. Again, that's quite a lot to consider, so I'm going to go ahead and graph this to help me. So we have x cubed minus 28x minus 48. So negative 4, negative 2, and 6 right there. Negative 4, negative 2, and 6. 4, negative 2, and 6. Those are our solutions. So negative 4, negative 2, and 6. And there you go. Now, when it comes to an actual quiz or an actual test, I would really rather not have you guys do a question where the rational roots theorem is required. Instead, if I ask for a rational roots theorem, I would basically just ask for you to come up with this right here, so the possible solutions. But I wouldn't have you really go through and check which ones are the right solutions, okay? So, okay, let's do one more. I'll do it in another video. This one will be using an example 5 from your notes, which is the irrational conjugate theorem.